All right, so the first part of this lesson, this is 12.1, 12.2. I'm just going to recap what we did in class today. So you shouldn't really need to write anything extra down. Also, you're welcome to add these notes directly to the notes that you've already taken since they're in that same section. Okay, so the first part is just us talking about arithmetic sequences, which we talked about today. Those are linear functions, so that means they create straight lines. And when we notice like the sets of numbers, we usually notice a set of, or we will always notice a set of addition or subtraction. So when we do this, we're going to have an explicit formula, which we talked about also today. This is the rearranged version that I think probably makes a little bit more sense to you all, just from what you're used to seeing. So f of n equals, remember D stands for that common difference, or that's the pattern. So if you're adding 7 each time, that'll be a 7. If you're subtracting 3 each time, that'll be a -3 out there in the front. The n right here stands for the term position that you're talking about, whereas f of n stands for the term's value. And then here at the end, and that should not say a of n, that should say a of 1, which I think, like I said, should already be written in your notes correctly. So this should be an a of 1 out here at the end. And that just means the first term. Remember, together, this gives you like the starting value. Inside's the opposite, outside's the same. And this one gives you whatever vertical change it is you're going to see when you go to graph that sequence. All right, so we kind of touched on geometric sequences and exponential functions in class today. We talked about drawing the tree. We talked about eating that pan of brownies and cutting it down every time. So I want to show you what that explicit formula looks like. This is coming directly off your formula sheet, so it's not one that you necessarily have to have memorized, though you should understand the structure of it. So this a of 1 is exactly what it was the last time. This is the first term. And notice that the n minus 1 this time is an exponent. So these two things together is what's making your starting point. If that had said n minus 5, that would have meant like the fifth term, right? Not the first term. The other part that we want to note here is r. That's the one that's different. This stands for the common ratio. So remember, in the other one, in arithmetic, we call it the common difference. This is the common ratio. It would help if I spelled that right. And it's whatever you're multiplying by every time. Now, I said that this is a pattern of multiplication or division, but what I really mean is this is a pattern of multiplication. I don't ever want you to use division, because when you go to write it, even though you might recognize it that way, you might not use it as division. So for example, if it's something that's you're going to have like growth with, so it's getting larger each time, that number needs to be greater than 1. For example, if you're like multiplying by 7, that's going to be getting bigger each time. All right, that's like times 7. If you have something that's decay, that's getting smaller each time, that means you're going to have a number that's less than 1. So if you had written, or you noticed that whatever the pattern is like, let's say dividing by 3 each time, instead of writing divide by 3, you're going to write that it's multiply by 1/3. So it's important that you realize that division by 3 should really be written as multiplication by the reciprocal. You're going to need to use multiplication every time. All right, so that's how geometric sequences work. All right, so if I give you one quick example doing the explicit before we move on to the recursive formulas. I notice this is geometric. I'm recognizing that this is dividing by 2 every time. You may not see it in the beginning, but you should see that at least near the end. But remember, we don't want to use division by 2. We want to change this over to be multiplication by the reciprocal. So that's multiplication by 1/2. All right, that's my pattern. And then I also need to note the starting point. So if I use like 96 as the starting point, that's my first term, which is going to be a starting point of 1 and 96. And you will have a table to do this from, like we did with those arithmetic sequences. So if I use the formula that we just wrote down, you can glance back up at your notes for that. This is going to be f of n equals, I'm going to start with 96. And since that's my first term, I'm going to put n minus 1 as the exponent up there. And then inside is going to be the pattern, which is multiplying by 1/2. So I'm going to put a 1/2 in there. I also want you to recognize, just because you might see it later on, you could pick another term. For example, I could pick 24 here, and that would be the same. It will end up being an equivalent equation, Just notice that when you write the exponent, you'll write n minus 3, because the third term is 24 with a 1/2 in the middle. All right, just recognize that these are for the same, they don't look the same, but they're equivalent. All right, let's look at those recursive formulas now. All right, so explicit formulas are all in one. So when you're explicit with someone, it means you're very direct, you're very specific and to the point. So explicit is all in one. It means that the starting point and the pattern are both going to be in the same formula. So we have these two examples. One of these is arithmetic and the other one is geometric. So notice that this first one, I'm going to recognize that this is, oh, that's not what I meant to write. I'm going to recognize that this one is geometric. And I recognize that because it's got an exponent up here. I know that the starting point is going to be 1, 3, because I've got the first term and the 3 out there in the front. And then I know the pattern is going to be multiplying by 2 every time. All right, another example over here, this arithmetic one. And you may not recognize the arithmetic or geometric at first, but we'll keep working on that. This one has a starting value of inside's the opposite, 4, outside's the same, 3. And then this one has a pattern. We're not multiplying by 2 anymore, we're adding 2. So this is a pattern of +2, which is making that arithmetic. So recursive, what recursive does is splits that into parts. It gives you 2 formulas that are going to work together to count from one term to the next. And sometimes they're easier to write. They're not always easier to work with, but you might see them, so I want to make sure that you get some practice working with them. So what I'm going to do is I'm going to write this in a recursive form. So what recursive form says is it starts by telling you what the first number is, and it is just, this is like one of the equations. F of 1 equals 3. And that's all it is. The value of the first term is 3. And then they write a separate one that has to do with the pattern, and it says f of n equals f of n minus 1. This whole thing, notice that's not n minus 1, that's f of n minus 1. It's another function, and this means the previous term. So it's the previous term, and what are we doing to it each time? We're multiplying by 2. Okay, let me show you another one to see if you can catch on. That is, in its entirety, that is the explicit form. It's recursive, I'm sorry. All right, let's look at this other example to see if you can kind of see it come full circle. So I've got this one, the starting point is f of 4, the fourth term, has a value of 3. And then I'll write another one, f of n equals the previous term, f of n minus 1. That whole thing means previous. And then we're adding 2 each time, so I'm just going to write +2. You take the previous term, and you add 2 to it every time. That's what that equation says. All right, so there's you an example of a recursive formula. If you want to label, just so you have it, even though I think you should, this is geometric, and this is arithmetic. And we will work with both of these in class tomorrow.